I'm Nick, and this is my 8th year competing in RoboFest. I love building and designing mechanical systems, so that's exactly what I did with our system here, as well as implementing the motion.
I'm Jurius. I've been involved in robotics for about 7 years, and I'm responsible for the image recognition and report generation code.
Our project is called C Cubed, also known as the Custom Camshaft Counter. Here at LSM Systems Engineering, we found a real-world application to use computer vision. They produce tens of thousands of camshafts every year, which are critical engine components.
Every week, LSM ships out many of these boxes containing 110 camshafts, which are mixed.
For each of these boxes, they make sure to count and log each different type of camshaft to make sure that they accurately represent what's in the box. But sometimes this representation can be wrong because it's time consuming and it's hard to make sure all these parts are correct. And there's a lack of quality photographic evidence because it's hard for a human to get every single camshaft perfectly in the frame. In the past, there have been many discrepancies between what LSM says they've shipped and what the customer says that they've received, which has cost LSM hundreds of dollars a month in manpower and parts.
Our solution is C Cubed, a mobile system which utilizes a camera running on computer vision software in order to be able to accurately identify each cam.
Let me give you a demo of our system. It's completely portable because we opted for battery power, and it has casters that raise and lower the system to make it portable. Here we have the view of what the camera sees and the region of interest, which is fed through this pipeline. You can also raise and lower the exposure. You can click anywhere on the screen to go to that box, and as you can see, a 2-axis motor controller is telling these stepper motors what to do. You can also tell it to move the camera. And as you see here on this camera, there's a 3D printed fixture which also holds this umbrella, which acts as a great diffuser and reduces glare.
So, this camshaft slot looks like it has a QR code, so let's see what our identification code returns. As you can see here, it successfully identified the QR code and its data. Let's move to another slot. This camshaft doesn't have a QR code. Let's see what it does. So, as you can see here, it's used template matching to identify the data. Let's move to another slot. So it looks like it wasn't able to use QR code detection or template matching to identify this. So it's asking me to manually enter the data. It looks like it's a C34, so I'll enter that. And now it pops up here. Let's move to a slot without anything in it. And as you can see, it says none because no camshaft was identified. This is how the code is able to detect if a camshaft is just present or not. So the first thing it does is it sends the original image through a pipeline, which is just first it converts it to grayscale, then thresholds, and then applies a morphological operation to it. Then every single contour is detected from the processed image that went through that pipeline. However, each contour detected is sorted using a custom function based on the whole area, because as you saw in the previous image, there's a lot of random contours that were detected. After sorting, this is the output. Alright, so this is how camshaft identification works. The first thing it does is it tries to rotate the image so that the text and QR code are upright. This allows for more precise data extraction. Then it'll try to decode any QR codes that it sees, but if that fails, then it'll try to do template matching, which is pretty much just comparing the input image to a template image, and then it returns the match. Then, if none of those work, then it'll open up a window where the operator can just input whatever text he sees.
Our system has been in place at LSM for about a month now. It's saved LSM a lot of time and money and has solved a lot of these issues with the customer very quickly. Our customer really loves our product, and we've even had a supplier say that they would love to purchase a finished product. We're still working on our final report and in improving some of our image recognition techniques, but we're almost there.
Okay, I have some questions for you. Nick, what was your biggest challenge in the mechanical system?
So after we got everything stiff and we got the motion working correctly, the biggest challenge was actually getting a high quality image. We had a constant problem with glare. No matter how many different cameras we tried, different lenses, a polarized filter, different lighting, nothing seemed to work. But actually, it turned out a simple solution of just using this white umbrella, which acts as a really great diffuser for the ambient lighting. It really did a good job at reducing glare and giving Jurius a very high quality image.
Jurius, what was your biggest challenge in identifying the camshafts?
So the biggest challenge in identifying the camshaft would have to be getting the template matching to work. So we found that if we correct the image by rotating it where the QR code and text are horizontal, template matching worked a lot better and is now very consistent.
Thank you so much for watching our presentation. We really hope you enjoyed.